Okay, today we're working on the fourth set of notes, and we're working on the radicals, but more PARCC-like type problems. So we're not doing every problem in this worksheet, so make sure you pay attention as to what numbers we are focusing on. So the first problem we're going to start with is number 1, and I want you to look at your multiple choice that is listed for you and notice that most of them are in exponential form. So the first thing we need to do is get these radical forms out and get this into exponential form. So this means this is xy raised to the 1/2 power plus 25 x to the 1/2 power. And using our exponential rules, notice x and y are both underneath the radical, so I could rewrite this as x to the 1/2, y to the 1/2. They both get that exponent. And now, based on your multiple choice, it looks like they pulled something out and then you're left with a binomial. So what they took out is a GCF. So we need to figure out what is the greatest common factor between the two. So numerical wise, they both have a 5 in common. Variable, they both have x to the 1/2 power in common. So if I took 5x to the 1/2 out, I'm left with y to the 1/2 plus 5. So looking at your multiple choice, letter D would be your option that you would select. So now we're going to skip down to number 3 on the page. And notice number 3 says if we have the square root of the cube root of x plus 1 to the 5th power, essentially how could I rewrite this as x plus 1 raised to this a power? So I don't want you to look at the right hand side at all. Focus on the left side and see how could we rewrite this. So we have this square root, this big square root on the outside, but if we just focus on this x plus 1, x plus 1 is the same thing as if I want to get rid of this cube root of x plus 1 to the 5th power, I could raise it to the 5/3 power. So that's coming from these values right here. But now I still have a radical, so I want to get rid of that. So I have this x plus 1 raised to the 5/3 power, but that whole thing is raised to the 1/2 power, and that 1/2 power represents this radical right here. And we talked about exponents. When I have a power raised to a power, that means I multiply my exponents. So this is x plus 1 raised to the 5/6 power. So if I now drop that right hand side, my value of a obviously has to be 5/6 because that would be the only exponent that would work. So my a value would be 5/6. Okay, we're going to skip number 4 and we're going to go to the back side and we're going to focus on 5, letter A. So I need to get rid of that square root, so in order to solve, we're going to raise both sides to the 2nd power. So on the left hand side I have x plus the square root of 2x equals 4. And again, I have a radical, so I will be raising both sides to the 2nd power, but before I do that, I want to get rid of this x, so I'm going to subtract that x over. So I have the square root of 2x equals 4 minus x. Again, raise both sides to the 2nd power to get rid of the radical, so I'm left with 2x. Right hand side, remember this is like 2 of them, so you're going to FOIL. So I'll have 16 minus 4x minus 4x plus an x squared. You could also do the box for that. So 2x equals 16 minus 8x plus an x squared. So I'm going to subtract that 2x over so I can solve, so it needs to be set equal to 0. And I'm also going to rewrite this. When I rewrite it, I have x squared minus 10x plus 16. Now in order to solve this, we're going to factor. So we're looking for two numbers that multiply to be 16 and add to be a negative 10. So I'm going to go ahead and flip the screen. So I have 0 equals x squared minus 10x plus 16. So a negative 8 and a negative 2 would work here. So I'll do the box for this one. So I have an x squared, a minus 8x, a minus 2x, and a 16. If you don't do the box, go ahead and do it your normal way that you factor. So I could take an x out and an x there. I could take a negative 8 and I could take a negative 2. So this factors down to be x minus 8, x minus 2. So my two answers are a positive 8 and a positive 2. Now again, we need to do the check here, so we're going to check both scenarios, my 8 and my 2. So plugging this into the original problem, I have 8 plus the square root of 2 times 8, and we need to see if this equals 2. So I have 8 plus the square root of 16. The square root of 16 is 4, so now I have 8 plus 4, and I get the square root of 12. And the square root of 12 does definitely not equal 2, so 8 does not work. Now I need to check positive 2. So I have 2 plus the square root of 2 times 2, and I need to determine if this equals 2. So I have 2 plus the square root of 4. The square root of 4 is 2, so I have 2 plus 2. 2 plus 2 is 4, square root of 4 is 2, and 2 definitely equals 2. So my solution would be x equals 2. So last problem we're going to do for the video is problem number 6, so skip 5b. We're going to go down to number 6, and the directions say to solve for p. So we need to get p by itself. And if I need to get p by itself, I'm going to raise both sides to the third power to get rid of this cube root. So on the left side, I'm left with 196. On the right side, I need to raise the 5 to the third power, which would be 125. And the cube root and the third power will cancel out, and I'm left with 14 plus p. And notice up here the operation between 5 and the cube root was multiplication, so it's still multiplication. So to solve, we need to distribute the 125. So I get 1,750 plus 125p, and that's equal to the 196. We'll subtract 1750 from both sides. So I'm left with negative 1,554 equals 125p. We'll divide both sides by 125. And when you divide both sides by a negative 125, you get that p equals a negative 12 point something on a decimal. So at that point, you should be able to look at your multiple choice and determine that the only possible option would be letter D. And letter D is negative 12 and 54 over 125 as our final answer. So that's all for today. We'll pick up with this tomorrow.